Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next of our series of What to Look For in the Night Sky. We're talking about the week of September 18th, 2023 this time around. Last week, we had very little moon interference, and we'll start this week with very little moon interference so we can look for some more interesting, fainter things than we might some other times. The moon starts the week at about 15% full. Beautiful. So right there, when you're going out on the 18th, the evening of the 18th, look for a moon that's about 15% full. Beautiful slender crescent in the west. As it gets dark, it'll be great to see. By midweek, the 20th into the 21st, it'll actually pass right over Antares, like I think it did very recently, but it'll be after it has set for me. So if you live west of where I do in the middle of the United States, you might have a better chance of seeing it. It'll still be pretty impressive. By that evening of the 20th, it'll be at 30% full for me, and we'll be approaching Antares, the bright orange star Antares in Scorpius. It'll be approaching it from the west, and so it'll be a fine sight. It's just as later and later and later as the clock turns over from the 20th to the 21st, it'll go right over the top of Antares. By the end of the week, the moon's 75% full. It's starting to wash things out. So several weeks ago, we talked about the summer triangle and Vega, Deneb, and Altair. And we said, for me, often I see the brightest star, Alpha Ophiuchi, the brightest star in Ophiuchus, or Rasalhague, as a fourth member of that, and it looks more like a summer diamond than a summer triangle to me sometimes, as I see the star. This star isn't as bright. To be clear, this star isn't as bright as the other stars, but I see this. So if you look at Vega, Deneb, and Altair, pretty high overhead right now as it gets dark. Still high as we head into fall. The summer triangle, just as it gets dark, is hanging high overhead. Vega is way up high. Drop down to see Altair to the south. You'll see Deneb on over to the east of that, just a little bit up high as well. But you drop down to Altair, and then come on over here to Rasalhague. Now, if we want to turn this triangle, the sub-triangle of the big summer triangle, Vega, Altair, and Rasalhague, the alpha star in Ophiuchus, if we want to turn that into its own diamond, we come over here and we say, where does that diamond end? Well, it ends right there at the keystone of Hercules. And so we can see the four stars that make up the body of Hercules right there. There are other stars for legs that come down this way and other stars for arms up this way. But we've got these nice four stars. Zeta is the upper right star. So look for this box of stars. Relatively bright stars, but not super bright stars. Magnitude 3.5 for Zeta. So nice big bright star, but not popping out like some of these other stars. We've got Pi at 3.7, Epsilon in the lower left corner, the way we have it drawn right here, at 3.9, and Zeta at the lower right corner is 2.8. So it's the brightest star in this group, and you want to see if you can identify that box. Now, if you have a telescope, we got a few interesting things for you to look at. M13, you might actually be able to see M13 with your binoculars if you've got good binoculars. It's the biggest, brightest, most beautiful globular star cluster we have in the northern hemisphere. Well worth checking out. You got a good dark sky, and you've got the water's dropped out. You got good seeing, good transparency. M13 is just a beautiful object in any small telescope that you have. So see if you can find that. It's about a third of the way down from Eta towards Zeta in the body of Hercules right here. Now, if you take Eta, if you take Pi as a hinge point and take Eta and swing it up this direction, so it's a little bit more. It's not quite isosceles up that way or equilateral up that way. It's back over toward Pi just a little bit more. You'll come to M92, another good, beautiful globular star cluster. So see if you can find those globular star clusters, these markers of summer that we look at, we see as we're looking toward the center of the galaxy. We've looked at them a couple of times this summer as we've talked about things to see. These globular star clusters are great. But we also want to take a moment to talk about Zeta down here, the brightest star in the body of Hercules right there, this lower right star of Zeta. Zeta is actually a binary star. Okay, it's two stars in orbit around each other, but the separation is pretty close from our viewpoint. They're very near us, but they're also pretty close together, so that their orbital period, a lot of these binary stars, the orbital period is tens or hundreds of years. And this one's 34 years, right? I think is the orbital period for Zeta at Hercules. And so with this 34-year period, we see it orbiting quite a bit, but it's also got an elliptical orbit. And so the two stars get closer and further apart, and it's actually a fairly tricky binary to pull apart. At their closest, we take a degree. Remember, your finger at arm's length is 1 degree. You divide that into 60 arc minutes. And we give that this symbol with the slash like that to say 1 degree, divide it 60 times, and you're talking about an arc minute. Divide it another 60 times. Every arc minute gets divided into 60 arc seconds. So an arc second is whatever that is, 3,600th of a degree. So it's a pretty small little division right there. It's an arc second. And these are separated at their greatest. These are separated by about 1.6 arc seconds, and they're less than an arc second at their closest. So they're pretty close to one another. And what makes this challenging for observers, you go out with your small telescope, try to look at Zeta. What makes it challenging for you is the fact that atmospheric seeing, unless you live someplace where you've got good, stable, dry air, and you don't have a lot of turbulence, a lot of stuff going on around you, you're going to have the air buffets the starlight around, and it spreads the starlight out, and it makes the star images. The stars are so far away from us that they look like points to our eyes. And even to most of our best telescopes, they look like points. Not the very best ones now, but not all the stars. But most of the stars, it's fair to say that most of the stars, nearly all of the stars, to most telescopes, look like points of light in the sense that they're so far away, the optics of your eye, the optics of the telescope you're using, they're not good enough to see the surface of that star as anything other, to actually see the left edge of the star resolve from the right edge of the star. They just merge together. And so what that means is the stars don't look like points to us in a telescope or to our eye, and that's because the starlight, the atmosphere is buffeting that starlight around and is spreading the starlight out, and we call that astronomical seeing. And most of us who live where I live have astronomical seeing that's a few arc seconds. So a star will have a diameter that might be a few arc seconds across. So trying to pull something apart that's only 1.6 arc seconds is hard, but you can still do it because the center to center, you can see that there's actually 2 centers right there. And now's the time to do it because now with this elliptical orbit, it goes from 1.6 arc seconds to less than an arc second back to 1.6. But we're at about maximum separation right now. So over the next half a dozen years or dozen years, these things are going to merge and be very difficult to see. But if you want to see Zeta in Hercules right here, if you want to see that pulled apart into a binary system, now's the time to go outside and do it because these things have the greatest separation out here, about 1.5 arc seconds. And you should be able to do it. If you have a good stable night, you might not see any dark space between the stars, but you should be able to easily tell that there are 2 stars there, I think. If you've got a good night for doing that. So there's your observing challenge. I like to give you an observing challenge each week. So what we want to do this week is watch the moon fill out and watch it get close to Antares, but also identify Vega, Altair, and Rasalhague, and then turn that into a diamond. And the right side of that diamond is going to be the body of Hercules, and identify the 4 stars in the body of Hercules: Eta, Pi, Epsilon, Zeta. And 2 globular star clusters, and then your observing challenge is to go out and observe the binary star Zeta Hercules. That's what we got for you, everybody. Hope you have a great week. Hope you have some dark skies and have a chance to get out and enjoy the dark skies. And as always, thanks for watching.